Hey, grade 8. I'm going to go through and do a little bit of these drafting questions with you and try to give you a hand in finding some of these answers within the textbook here that I've got online. So I've photocopied and uploaded this as a PDF to your Google Classroom, and it has the textbook Drafting Fundamentals. This is right out of there. And so today, this quick video here is just going to be about how you answer these 10 questions here. You're going to find the answers on page 6 to 30, and so you'll notice that the photocopying, that your text should start on page 5 and go from there. So let's get right into it. So define some of the following terms, and then just notice that it says use a picture. So you're going to try to draw a picture of each of these things, and obviously we're not all artists, but you're going to do your best. And on this first page are some T-squares. Okay, I showed some T-squares in my video yesterday or the other day there about the drafting introductory. But within this, on page 6 here, you'll find what a T-square is. But basically it's just used to draw those horizontal, vertical, and basically just horizontal and vertical lines, not really the inclined too much. The inclined lines are going to come from your set squares, and set squares is the second one. So these two triangles here, which are these two guys. Okay, these guys here, they have a 30 degree, 60 degree, and a 90 degree angle on one of them. Okay, that's this guy, and then a couple of 45s and a 90 on the other one. And so we use these in drafting when we're making pictures of different things we're going to build or trying to make a design. So those are set squares, and as you can see here, set squares are used to draw these different angles, and I referred to this yesterday about the 30 degree, the 60 degree, the 45 degree, and of course the 90 degree are very common angles in buildings, stairs, roofs, walls, all those kind of things. And so that's why we have these specific angles, easy to access, easy to make. And then every once in a while you'll actually stack them up like this, where you could take a 45 degree angle and you could add a 30 degree angle, and together, well, what's 45 plus 30? You got a 75 degree angle. You could throw in a 60 with a 45, and now you're at 105. And so it just makes a lot of common angles. For some of those not so common angles, well, yes, of course, you're going to need something this, a protractor. Okay, and we talked a little bit about a protractor the other day as well. The next one are scales. Okay, and so this is a scale. It's actually what we would call a scale ruler. But you'll notice here it has like a 1 to 5 scale, a 1 to 2 scale, a 1 to 1 scale, and then down on the other side 1 to 10, 1 to 50, and 1 to 20. So this particular ruler or scale ruler will have the ability to give you 6 different scales. And basically what that means is a 1 to 1 scale. Okay, so a scale that we see here, it should match up quite directly with I got to get my millimeter side here, with a ruler. So if I was to put the 0 of my ruler, it should count up the exact same. So it's a 1 to 1 scale, or they call that a full scale, just like on a regular ruler that you'll see. And then when you jump to a 1 to 2 scale, well, now you'll notice that 1 centimeter is actually 2 centimeters on this scale. So it shrinks it by a half, or by 2. Then you get to the 1 to 5 scale, and you'll see that 1 centimeter is 1 centimeter on my full scale ruler, my clear one here, is equal to 50 millimeters, which would be 0.5 of 5 centimeters. So 5 centimeters, obviously it's 5 times smaller. And as you get up here, it shrinks a meter down into this space, so 50 times smaller than what a regular meter would be. And when you're using a scale ruler such as this, you're using it to reduce the size of a picture Maybe you're trying to draw a picture of a car. You're designing a new car, or you're designing a deck for the backyard, or something that's obviously a lot bigger than a piece of paper. You need to use a scale ruler to scale it down, but still keep it proportionally the right size. And so that's what a scale ruler is for, and that's what it looks like. And the last one is a compass. And here's my compass. Okay, and we'll look on to... Oh, you know what? Yeah, okay, I'll quickly go and see where the compasses are. Okay, so here's the compasses. Okay, you've got some compasses here. But this is a compass. And you see it obviously has the point for staying in a piece of paper, and then the pencil point that allows you to draw the line or the circle. Different arcs and circles of different sizes is what we would use a compass for. And you can see that this one looks like the bow compass. Okay, it's a very sturdy, accurate compass, and you've got this wheel in the middle that allows you to make it bigger or smaller. This guy on top here gives you something very handy to grab onto and to turn around, and this just keeps things very rigid and stiff. This pencil can be removed. You loosen here, and you put a new pencil lead in there. And then this point, if it gets dull or just kind of wears out and you need to replace it, it can also be replaced. So this is a really good compass. So that's kind of those first four terms there. You can use the notes in your textbook here to help you with those. But then I want to get into a little bit about the scales. And on this this page here, this is page 7, you'll notice that it's got some scales. It starts talking about scales here. It shows you some of the scale rulers. But then up here it talks about what a full scale is, which is 1-to-1. And remember, we talked about a regular ruler is a full scale. It's a 1-to-1. So it's accurate. You measure, and whatever that says, that's actually the real life measurement. Then you'll get into things like when you're trying to draw ships or buildings or airplanes, okay? And you'll get into scales like 1 to 50. So anytime the number 1 comes first, okay, 1 to 50, 1 to 20, 1 to 1,000,000, that means that you are reducing the size from a real life object, like maybe a landmass such as Canada, and reducing it to fit onto a piece of paper. So this would be a reduced scale with the number 1. And whatever the second number is, that's how many times you're reducing it. It's that many times bigger in real life. So if something measures 1 inch on a page on a 1 to 50 scale, that means it's actually 50 inches long in real life. Now here, underneath there, it talks about an enlarged scale. This one was reduced down here. When you get the number 1 coming second, so 5-to-1, 50-to-1, 100-to-1, now we're talking about an enlarged scale. So this is something that's really small, maybe a hair follicle or a cell, a skin cell, or an insect, and it's you don't want to draw it to its real size on a piece of paper because you want to see the details, so you have to draw it larger. You have to enlarge it. And this is telling us how many times we're making it larger. So 5 times larger, 50-to-1 would be 50 times larger than it is in actual real life. Okay, so that's kind of the idea behind these questions here about what's the difference between these scales, describe with an example from the scales, which is considered reduced and which is enlarged. Okay, now the title strip. Okay, your title strip question. You're going to find the title strip answer in here if you strum through your pages right here. Okay, you'll see title strips and blocks. At the bottom is an example of a title strip, and it describes what's in a title strip. So you'll find that, you can see there on page 15. Next question is hidden lines. Okay, and again, we're just going to keep flipping through these until we get to hidden lines. So here's hidden lines. We're on page 18. Talks about hidden lines. But basically, you can see here, here's a fence board. Okay, this is like a gate on a fence. And you've got the vertical boards here, a couple of horizontal boards, and then a diagonal board holding it together. And when you draw that picture, you know that this line here, there's a board behind there, but you don't draw it solid because it's behind. This board here is at the front, and so it's a solid line the whole way. Anywhere where you can actually see it from that view, from that angle, it's a solid line. If you can't actually visually see it, but you know it's there, you need to do it as a dashed line. Okay, so hidden lines are dashes. And for example, if I showed you this, you'd say, okay, that looks like a triangle. It has a hole in the middle of it. That's pretty easy to see from this view. But if I was to turn this object like this, and now you tried to tell me, what does this thing look like from the front? You wouldn't really be able to tell from this particular view. Obviously, if I tilted it a little bit, now you can see that hole again and the shape. But from here, it just looks like it's a straight line. And really, it doesn't look very much different than what this guy looks like from the edge. Looks like a straight line. So who knows which is which? Could be the same thing. So the thing that tells us what an object looks like is the different views. And the different views also have to have parts to it, like these dotted dashed lines, that tell us things that are happening that we can't necessarily see. And so that's what a hidden line is. It's created like that, and it's there as a view of something that's actually there, but we can't see it. Okay, what is sketching and why is it an important part of the process? Okay, so sketching will be a few more pages in here. I don't think you guys do curves, circles, or arcs. That's the grade 9s, but drawing some irregular curves is a different grade. So here's sketching. Sketching's on page 25. And it talks a little bit about sketching here. Basically, sketching is a freehand drawing. Okay, so this picture that they've got here, obviously there's some hidden lines, but you'll notice that they're not perfectly straight. So a ruler was not used to create this line. You can see that this line here is a little bit wobbly, which just means it was freehand drawn. And the important part about sketching versus the other aspect of creating a design, which comes down to drafting, I don't know, we don't talk about it in detail here, but sketching is the first draft, the rough draft, the initial process of putting a plan together. It does not use straight edges, it does not use scales for the most part. You want it close, but it doesn't have to be 100% accurate. It's more about getting a picture. And so when this question asks you, what is sketching and why is it important? Well, that's a pretty simple answer. It's just that initial process. It gets your thoughts from your head down onto a piece of paper. And it's a really important part of any initial design. Whether you're trying to design a concrete pad for your driveway or putting a wall, changing a bedroom around by rearranging a wall, or building a new, renovating your bathroom, all those things are going to take a plan. And your initial plan just needs to be a quick drawing to get your ideas down. You add, you subtract, until you get to the point where you need to get into an accurate draft. Okay, we'll get into some of those shapes and things later on. But that would be getting into more of the accurate with straight edges, with scales, with protractors, with compasses, and that would be drafting. So that's a big difference between sketching and drafting. Okay, so they're asking for some key differences in number 7. So I kind of gave them to you a little bit about the accuracy with the drafting, the scale drawing, straight lines, clean, neat, easy for a builder to read. So somebody on the construction site needs to easily be able to read what you've put into play, whereas the sketch is that initial picture, that initial idea. Okay, the orthographic drawing looks at 3 views or faces of an object. What are they? So we're going to look for the orthographic pictures, or right there's an orthographic picture. Okay, and it's going to get into a little bit more detail right here. So they'll call it pictorial views. Right here is an isometric, and then orthographic projection, which is an orthographic drawing. And it takes this pictorial view, or an isometric picture, and it takes the top. So this is also the top right here. It takes the front right here, and it takes the side. This is also the side, and it puts it here. So this we would call isometric, and we'd call 3D. This is a 3D picture. It gives you length, width, and height. This is a 2D picture, but there's 3 of them. So this guy has length and width, length and height, height and width. 2 dimensions for each of the pictures, but there's 3 of them, so you really do get a good idea of what the object looks like. Now, we are going to do a lot of studying, a lot of information, and work around the idea of orthographic and isometric. That's a really important topic within the grade 7, 8, and 9 IA curriculum. And we want to really have a deep understanding of what the difference between the two is, what the importance of them is, and how they're always drawn and laid out. And that's what a lot of your assignments in this package down here are going to be about. Okay? Now it talks about the 3 faces. What are the 3 views? Top, front, side. How are they laid out? They're always laid out in what I call an L shape, where the top is directly on top of the front, and all of the edges match. Any changes in plane, so from here it goes down, so it goes from horizontal to vertical to horizontal to vertical. Any of those changes in planes will always line up. And these two are always the same height, with any changes in plane lining up. And a plane would just be an edge. A vertical plane, a horizontal plane, and in some cases an inclined plane, but not in this picture. Okay. Number 9, the difference between an orthographic and an isometric. So I just kind of described that there. The 3D versus the 2D. The single picture versus 3 parts to the picture. The layout. Okay, the layout of a tilted picture. And then for what shape are 2 views usually sufficient? Right here it talks about 1 view drawing. And then on the next page it talks about 2 view drawings. And I want you to go through and give your own answer for that. So, I hope that little video there helps you with these first few questions. Page 6 to 30, and there we are, we're on page 30. And we've found all of our answers. So, I'll make some more videos for these guys here, and I'll post them on the Google Classroom very soon. But this one I hope will help you with the first 10 questions.